This is the last part of Chapter 7, Section 7.3 on assessing normality. This is a very quick and easy topic for us. For large data sets, we consider large anything more than 30. We can glance at a histogram and see if the data are approximately normally distributed. So we can just look at the histogram, look for that bell shape. For small data sets, and that's if the sample size is less than 30, we have to be more careful. So we use what's called the normal probability plot to determine if small data sets are approximately normal. Now your textbook goes into how to get the probability plot by hand. I am not going to make you do that. We just need to know what the graph's supposed to look like. So what we have is a small data set. I think these are 6 dogs at the greyhound race. So finishing times of a particular dog in 6 greyhound races. So we have 6 data points, which is a very small set. We're going to number them 1 to 6 from least to greatest. We're going to work a little bit of magic here, and this comes from calculus, this little FI score. Not going to worry about how to do that by hand, but you kind of work this magic and you give yourself an expected z-score. So what you need to know is that we have the observed values on the x-axis and the expected z-score on the y-axis. What they do is they determine if this value was from a normal distribution, what would its z-score be? So for each value, it comes up with this expected z-score. Now we're going to let the calculator work this magic for us. So the calculator is going to do that part and give us an expected z-score. Then we plot the x values along the horizontal and the expected z-scores along the vertical. And so we have this scatter plot of the two variables, x and y, which is your z-score. If the plot is approximately linear, and I say approximately, you can just use your pencil to kind of eyeball, it's approximately a straight line, then the data are approximately bell-shaped, which is a good thing. We need them to be bell-shaped to run our calculations. So if you look at the graph here, and I can't zoom in, so hopefully you can see it clearly on your handout. You have all the individual x values, and what I want you to notice is the expected z-scores. Zeros in the middle, negative z-scores are down here, positive z-scores are up here. So lower times should correspond to lower z-scores, which they do. Middle times should correspond to z-scores around 0, which they do. And higher x values correspond to higher z-scores, which they do. This creates a roughly straight line. So if your scatter plot is roughly linear, we know that the values that we're getting are falling about where they should on the bell curve. So again, if the plot is approximately linear, using your pencil to kind of check, then the data are approximately bell-shaped. So let's look at some examples of approximately linear and not approximately linear. So if we look at the first output here, this is from a statistical software. Here's your scatter plot. They've kind of drawn a rough line through it. And the question is, do the data points kind of hover around that line? And it's just a quick visual check. There's no measuring, no calculating. You're just trying to visually check, yes or no, are they roughly on a straight line? And these kind of outside guides kind of help you see it. If we look at the second example, the scatter plot is making this kind of snake motion, almost a cubic function. And notice that it does not fall nicely along that straight line. There's clearly some other pattern going on there, so that you can quickly tell that that is not approximately bell-shaped. This next one here, your data is kind of in this parabola sort of shape. Again, they're not following nicely along that line, so they're not approximately linear, not normal. And then this last one, you can see your data points are tightly fit around that straight line. They all fit within those boundaries, so that last one is approximately linear. So it's a very simple visual check. It's no measuring, calculating, nothing. Just do they look like they're approximately in a straight line? So I'm going to teach you how to put this in the calculator so that you can see the plot for yourself and determine whether or not it's approximately bell-shaped. So the first thing you want to do is put your raw data into L1. Here are the steps from the textbook. So put all this data in L1. There's 25 data points. You can put them in any order in your L1. So stat, edit, put all those guys in L1. I've already done that for both of my calculators. So all 25 data values in L1. Pause the video if you need to get all those guys entered. From there, once they're all entered, you're going to push second y equals to access what's called the stat plot. So above the y equals button is the word stat plot. So y equals is in the top left. We're going to hit second y equals, enter. We did this for box plot. Make sure the plot is on. Then you're going to go down and you're going to choose the very last graph. The very last graph. So down, over, the very last graph. Don't go down again on the older calculator. Just keep going over until you get to that last graph. The data list is in L1. The data axis is the X. For the mark, again, you want to choose a bigger mark, either the plus or the box. It doesn't matter. And then if you have a color calculator, you can change colors if you want to. It doesn't matter. And then you're going to hit zoom. Always hit zoom. Option 9, zoom stat. Sorry, it's a little washed out here. So zoom, option 9. And you should see your scatter plot. And again, you're just roughly checking with your pencil, does it roughly make a straight line? You don't have to sit there and measure and deviate and all of that. Just, is it roughly in a straight line, yes or no? So that image is here. What I want you to label is that your X values are here. They go all the way from 0 up to, what's the highest, 36. So that last value is 36, and all the values in between. And that this is your z-scores. They go from -2, -1, 0, 1, and 2. So again, your lower X values should have lower z-scores. Your middle X values hover around that z-score of 0, and your higher X values are higher z-scores. So yes, approximately normal. Nice and simple for section 7.3.